Hey everyone, welcome to another episode in Physics is Fun. Today is going to be about more force and tension in a system. Let's jump into reading the question. From the drawing, which has massless rope and a frictionless pulley, solve parts A through C. A. Draw an FBD of each part of the system. B. Find the acceleration of A sub 2. C. Find the tension of T sub 1, T sub 2, T sub 3, and T sub 4 in the rope. Let's draw the picture needed. There is a ceiling in this table here that has a mass on it and a fixed pulley on the corner. There is rope attached to the mass that goes over the pulley and loops down and around another pulley to come up and attach to the ceiling. On this other pulley, there is more rope that hangs and holds up another mass. Label the mass on the table M sub 1 and the other M sub 2, and the tensions from left to right T sub 1, T sub 2, and T sub 3, and the final T sub 4 below. With the picture drawn, let's move on to solve for each part. Part A being FBDs. Start out with mass M sub 1 and a base, and all of these are on the same x and y axes. The block has weight, so M sub 1 times g down, and the block is on the table, so exerts a force back up with normal force N sub 1 on the positive y direction. The string is pulling from the right, so the tension T sub 1 goes out in the positive x direction. Now for mass M sub 2, start with the base, and it also has weight, so M sub 2 times g down in the negative y direction, and is being held up by the rope with a tension T sub 4 in the positive y direction. Now for the pulley, we can kind of ignore the fixed pulley, and so for the floating pulley, start with a base and the rope holding the mass down, so the tension T sub 4 in the negative y direction, and it is held up by the tensions T sub 2 and T sub 3 in the positive y direction. Now let's find the sum of forces for each section in the x and y directions. Well, looking at them all, only the M sub 1 has x, so the tension T sub 1 will equal to the movement M sub 1 times A sub 1. Now first we have to clearly understand that in this system there are two different strings with two different accelerations for both masses. For now I'll make them different and go through a more detailed explanation. So T sub 1 equals M sub 1 times A sub 1. Moving on to the y direction, M sub 1 has M sub 1 times g minus N sub 1 equals 0. M sub 2 has M sub 2 times g minus T sub 4 equals the movement M sub 2 times A sub 2, due to different acceleration than M sub 1. And the pulley has T sub 4 minus T sub 3 minus T sub 2 equals 0. Let's rearrange and simplify these equations. So, M sub 1 times g minus N sub 1 equals 0. Adding the N sub 1 gives just M sub 1 times g equals N sub 1. The weight and normal force are equal here. And the pulley T sub 4 minus T sub 3 minus T sub 2 equals 0. Add both T sub 3 and T sub 2 to get T sub 4 equals T sub 3 plus T sub 2. These equations should be better to work with. Before moving on from A, let's look back at the drawing and mark some things. We have to remember tensions are a constant in the same string. In this problem we are dealing with multiple strings. In the problem we have one string that connects the mass and loops around some pulleys. This gives the T sub 1, T sub 2, T sub 3, and they are all following along the same string. So in fact, all these tensions are actually the same. So T sub 1 equals T sub 2 equals T sub 3. And I'm going to mark this tension as just T now equal to the same as all those. For the acceleration of mass m sub 1, it will move in the positive x direction as opposed to m sub 2, where it will move in the negative y direction. Within the system, we need to be able to find a relationship or ratio between these objects. I believe we are really making an educated assumption on this, and it is not 100% exactly correct. Mass m sub 1 has just one link to the rope that loops around the pulley that holds the other mass. Thinking about this, if we were to pull the rope or see it move throughout the pulleys, it will move the same distance along each part of the rope. So around the fixed pulley, it will move a distance on both sides of it. Looping around the other pulley now, the rope will go the distance for both sides of the rope. So if the rope around the fixed pulley moves a distance x, the other pulley has two parts of the rope that then will move this same distance x. So this other pulley will move twice as far, and thus actually twice as fast as the other. If m sub 1 then has acceleration a sub 1, then in terms of m sub 2 and a sub 2, it moves twice as much and as fast as the first. So a sub 1 equals twice of a sub 2. So looking back at the picture, the fixed pulley really only has one point where the rope touches, as opposed to the other that has like 2 points where the rope touches. So hopefully this is an easy way to kind of look out for different accelerations. And with all the info written and simplified equations, let's finish part A and move to part B. Now to find the acceleration for a sub 2, we know it is twice as much as a sub 1. And with a relationship, we can substitute and solve for a sub 2. We have the tension T equals m sub 1 times a sub 1, and T sub 4 equals T plus T, which equals 2 times T. So now it's time to calculate. We know what T sub 4 is, so let's use that to substitute. So rewrite the m sub 2 times g minus T sub 4 equals m sub 2 times a sub 2. Rearrange and substitute for T sub 4 to get m sub 2 times a sub 2 equals m sub 2 times g minus 2 times t. Now we know what t is, so let's sub that in to get m sub 1 times a sub 2 equals m sub 2 times g minus 2 times m sub 1 times a sub 1. Now we know what a sub 1 is in terms of a sub 2, so sub that in to get m sub 2 times g minus 2 times m sub 1 times 2 times a sub 2. Now let's solve for a sub 2. M sub 2 times a sub 2 equals m sub 2 times g minus 4 times m sub 1 times a sub 2. Add 4 times m sub 1 times a sub 2 to both sides and cancel the right side to get m sub 2 times a sub 2 plus 4 times m sub 1 times a sub 2 equals m sub 2 times g. Factoring out the a sub 2 from the left side gives a sub 2 times 4m sub 1 plus m sub 2 equals m sub 2 times g. Now divide both sides by 4m sub 1 plus m sub 2 and cancel on the left to get a final acceleration of a sub 2 to be a sub 2 equals m sub 2 times g divided by 4m sub 1 plus m sub 2. With part B solved for, let's finish and solve for part C. Now to find all the tensions in the rope, we know that T equals T sub 1 equals T sub 2 equals T sub 3, and T equals M sub 1 times A sub 1, and with that, let's calculate. T equals M sub 1 times A sub 1, so let's substitute in A sub 2, which equals m sub 1 times 2 times a sub 2. We know a sub 2 is, so let's substitute that in. T equals 2 times m sub 1 times m sub 2 times g, all divided by 4 times m sub 1 plus m sub 2. That is the same for t sub 1, 2, 3. So to solve for the final t sub 4, we know it is 2 times t. So let's sub t in and get t sub 4 equals 2 times m sub 1 times m sub 2 times g, all divided by 4 times m sub 1 plus m sub 2. And the answer for t sub 4 equals 4 times m sub 1 times m sub 2 times g, all divided by 4 times m sub 1 plus m sub 2. All tensions are solved for, so part C is complete. After looking at the picture, we were able to draw our free body diagrams out and solved for acceleration. A sub 2 equals m sub 2 times g divided by 4 times m sub 1 plus m sub 2, and tension T equals 2 times m sub 1 times m sub 2 times g, all divided by 4 times m sub 1 plus m sub 2. And finally, tension T sub 4 equals 4 times m sub 1 times m sub 2 times g, all divided by 4 times m sub 1 plus m sub 2. I hope these intro problems are as helpful for you as they are for me. Thanks so much for watching. Hope you come back to learn more exciting material, and see you next time.